Oximetry is a medical exam that determines or measures the level of oxygen in the blood. This procedure can take about 30 to 60 seconds. Oxygen enters the lungs and then is passed into blood. Blood carries the oxygen to the various organs in our body. The main way oxygen is carried in our blood is by hemoglobin. 1 gram of hemoglobin is equivalent to 4 molecules of oxygen. So, oxygen saturation is referring to the percentage of the available hemoglobin that carries oxygen. Oximetry is done by using an oximeter. This is a photoelectric device especially designed for this purpose, to measure the oxygen in blood. So this device can be placed in the finger or in an earlobe. The rank of this exam goes from 95% to 100%. So, a pulse oximeter works by passing a ray of red and infrared light through a thin base. The ratio of red to infrared blood light transmitted gives a measure of the oxygen saturation of the blood. What the oximeter does is it classifies the blood. The oxygenated blood looks up of a brighter color than the disoxygenated blood, which has a blue purple color. The oximeter first measures the sum of the intensity of both shades of red. This is representing the fractions of the blood that we are with and without oxygen. This device detects the pulse and then subtracts the intensity of the color detected when the pulse is absent. The remaining intensity of the color represents one of the oxygenated red blood. This is displayed on the electronic scene that is in average 95 to 100%, as I already told you. So now the physical properties used in pulse oximetry. The amount of light absorbed depends on the following. First, concentration of the light absorbing substance. Second, length of the light path in the absorbing substance. And finally, oxyhemoglobin and the deoxyhemoglobin absorbs red and infrared light differently. So in the first physical property, we can see that the amount of light absorbed is proportional according to the blood vessel. So in the first diagram, we can see that one blood vessel has a low Hb concentration, and in the other one, the blood vessel has a high concentration Hb. So the both fingers have the same diameter, but if the blood vessel is different, the amount of light absorbed will be also different. So now the second physical property. So we can see that the amount of light absorbed is proportional. Like each of the amounts are proportional. So both arteries have the same concentration. However, the artery on right is wider than the one in the left. So at last, we can see that light wavelengths are very short. one is 650 nm, and the other one is longer, is 950 nm. Nm is nanometers. So, oxyhemoglobin and deoxyhemoglobin absorb light in a different wavelength and in a specific way. To conclude, I think oximetry is a very precise exam. It's really fast. It only takes a few seconds, and it really examines our body. And yes, I think it's really good in medicine, and it will help us a lot to to find oxygen, how many oxygen it is in our body.
Absorption of waves by matter. Light waves across the electromagnetic spectrum behave in similar ways. When a light wave encounters an object, they are transmitted, reflected, absorbed, refracted, polarized, or diffracted, or scattered depending on the composition of the object and the wavelength of the light. Especially instruments on board NASA, spacecraft, and airplanes also is used in medicine to do a variant of exams. Um, this thanks to this data can reveal the physical and chemical composition of the matter. The absorption. Absorption occurs when the photons from incident light hit atoms and molecules and cause them to vibrate. The more an object molecule moves and vibrates, the hotter it comes. This is the heat then emitted from objects as a thermal area. Some regions of darker colored objects absorb more incident light than others. For example, black pavement absorbs most visible and new energy reflects very little. While like concrete side walls reflects more energy than it absorbs. According to this information, we can do the question for medicine. How does the body absorbs the X-rays? First of all, X-rays are basically the same thing as the visible light rays. Both are wave-like form of electromagnetic energy carried by particles called photons. The difference between X-rays and visible light raises the energy level of the individual photons. This is also expressed as the wavelength of the rays. Our eyes are sensitive to this particular wave of visible light, but not the shorter wavelength and higher energy or no X-ray waves or no longer wavelength of the low energy, the radio waves. The soft tissue in your body is composed of a smaller atom, and so those not absorb X-rays photons particularly well. The calcium atoms make up your bones are much larger, so they are better absorbing X-ray photons. And thanks for the calcium of the atoms, our body can absorb the X-rays and can show how our bones or different parts of the body. Thanks to the X-rays and how our body absorbs them, there is a exam called the CT scan. It's a computed tomography CT, as is known. A scan is an imaging method that uses X-rays to create a picture of cross-section of the body. This is performing you are asked to lie on a narrow table that lies into the center of the CT scanner. Once you are inside the scanner, the machine every beam rotates around you. Modern spiral scans can perform the exam without stopping. So we can see that thanks to the matter absorption, we can define that the matter absorption is a great help on medical issues, and thanks to that our body absorbs the X-rays in a good way, we can use them in favor of our medicine. This is a very important topic and a very important thanks to the way of absorption of our body and to the principle of physics.